Before we begin, I do want to mention that today's webinar will be recorded and this presentation will also be in English only. So for anyone interested, we do have upcoming webinars that will be presented in French. So if I can just draw your attention, I'm just going to read off a brief disclaimer. This presentation and the information herein are provided without a prejudice basis and does not constitute nor should be construed to constitute legal advice or guarantee, offer, representation, or warranty on behalf of Tormont. The panel members will be offering suggestions to several possible customer scenarios, and the answers given by the panel members should be used as a guide. Next slide, please. So if any of you are familiar with Tormont, you know that we never begin a meeting or a webinar without conducting a safety talk. So I'm going to give you a brief safety talk, and today we would like to highlight the issue of cybersecurity. So whether you're using your cell phone or a computer, keeping those operating systems on your devices updated is really one of the easiest ways to protect yourself. Updates often include patches that can fix vulnerabilities or bugs that hackers can exploit, excuse me, in an attempt to access your system or your data. So I'm sure many of us are guilty when ignoring the prompt on your computer or your phone that you need to do an update because it's never at a convenient time, but it actually is really important not to ignore those prompts. Cybersecurity is also just as crucial when selecting the kinds of products that we are about to speak about. So that concludes the safety talk. Can you move to the next slide, please? So I do want to let everybody know that there will be time at the end of the webinar for a Q&A session. And we will be providing this email that you see on the screen where you could submit your questions to us at any point during the webinar. And we will address as many questions that we can during the Q&A. And if we are unable to get to your question, we will most definitely reach out to you following the webinar to address your question. So the email, as you can see, energysolutions@tormont.com. And you will see that repeated, that email should be visible to you throughout the presentation. Next slide, please. All right, so with that, pleasure to introduce our guest speakers to everyone. So I will begin with Joel Cormier. Joel is a senior electrical application specialist with Tormont Cat Power Systems, and he works with our sales team across our entire territory, providing electrical solutions and pricing for our customers. Joel has 14 years experience in the electrical industry, including power distribution and working with customers across a wide range of industries, and is a certified electrical engineering technician, and also has Red Seal endorsement as an industrial electrician. Welcome, Joel. Thank you for joining us.
Thank you.
Next up, I'd like to introduce Akhila Shankar. Akhila is a senior consultant account manager for Tormont Cat Power Systems. She has been with Tormont for the past 17 years and is a professional engineer with an electrical engineering background. And she has extensive experience in generator manufacturing, switchgear, and transfer switch industries. Akhila is also responsible for supporting our consultants in Southwestern Ontario, Manitoba, and the Atlantic provinces. Hi, Akhila. Thank you for joining us.
Good afternoon, everyone.
And last but not least, I'd like to introduce Habib Aleemi, who is a senior electrical application specialist for Tormont Cat Power Systems. And he has been with Tormont for the last 15 years. Habib's background is in electrical engineering, and he has worked across many different departments in our organization. And currently, Habib works with our sales team, providing solutions for switchgear and controls. He also reviews customer drawings and specs and recommends solutions for various applications. Habib, thank you for joining.
Thank you.
Great. So can we move to the next slide? All right. So I'm going to begin with Akhila. And I'm wondering, Akhila, if you can provide us with some examples of when you might utilize a battery energy storage system over a UPS.
To answer your question, Megan, I will start with a comparison of the UPS and the battery energy storage system. The UPS, or the uninterruptible power supply, and the battery energy storage system are similar in that they are both used to provide backup power, but they do differ on various other factors. If we can go to the next slide, please. So in terms of the energy storage and release, A UPS is designed to store small amounts of energy and release it over a short period of time. A UPS provides immediate short-term power during a power outage or during power fluctuations. This typically lasts anywhere from a few minutes to a few hours, whereas the battery energy storage system is designed for energy management. It provides high stored energy, that is high power over longer periods of time, ranging from hours to days. In talking about the purpose of a UPS is to ensure the critical devices and the systems remain operational without interruption during a power system outage. This allows time either for a safe shutdown of the equipment or for switching over to an alternative power source. The battery energy storage systems, on the other hand, plays a critical role in managing the complexities that are associated with integrating renewable energy sources or maintaining grid stability. And this is, of course, in addition to providing backup power during a power outage. Now, if we compare the components, a UPS comprises of batteries. It has an inverter to convert DC power to AC. It has surge protection to guard against power spikes. And lastly, it has monitoring and control systems to manage the power flow and battery status. Similarly, a battery energy storage system also comprises of high-capacity batteries. It has inverters/converters for managing the flow of electricity to and from the batteries. It has systems to monitor and optimize the battery health and efficiency. But unlike the UPS, a battery energy storage system has additional controls that are required for integration with the grid systems and with renewable energy sources. Now, looking at the application, the UPSs are primarily used in IT environments such as data centers, server rooms, and networking equipment. They're commonly found in healthcare facilities to ensure continuous operation of critical medical equipment. And in office settings, we find the UPS protects our computers and other electronic devices. Whereas the battery energy storage system can be used from small residential systems all the way to large grid scale installations. They help increase the energy efficiency, improve power quality, and support the integration of renewable energy sources.
Great, thanks, Akhila. So just to summarize, what you're saying is the fundamental difference between a UPS system and a battery energy storage system is a UPS is good for short-term backup power, whereas the BESS is better suited for a high energy density source of power.
Yes, that's correct. UPS is good for instantaneous, short-term, limited capacity backup power with zero transfer time during an outage. If we can go to the next slide, we'll be looking at where battery energy storage is a better choice as compared to a UPS. Similar to the UPS, a battery energy storage system also enhances energy reliability and security by providing backup power. However, when battery energy storage systems are used with one or more of the power sources, like the utility grid, an engine generator or turbine generator, or renewable sources like the solar or wind, as shown on this slide, it offers several advantages. So let's look at the residential application. The solar energy from the PV photovoltaic panels is stored in the batteries, and this stored energy helps reducing electricity bill. In a microgrid application, for say a remote area or a critical infrastructure, you will see the battery energy storage system is a critical part for integrating renewable energy sources. In an off-grid application, the battery energy storage system integrated with the renewable energy from solar or wind improves the energy efficiency, it reduces reliance on fossil fuels, and provides energy independence. And in the case of utility scale application, the battery energy storage system helps balance the energy supply and demand, and it supports grid stability and regulation.
Great. Thanks, Akhila. Can you elaborate on the synergies between a BESS with generators, renewable power sources, as well as the utility?
Sure. If we can go to the next slide, please. A lean burn natural gas generator set has poor block load acceptance capability. So in the absence of grid power or power from battery energy storage systems, a lean burn natural gas genset can stall when more than 30% of its rated capacity is added as a load in one step. The battery energy storage system enables the lean burn natural gas gensets to operate in an island mode. Also, when you have battery energy storage systems with multiple generator sets, the stored energy from the batteries can be used, so one or more generator may be shut down to save on the fuel consumption. Now, when a genset takes on load, it results in transient voltage and frequency dips, which means poor power quality to the loads. When battery energy storage system is used in a combination with the generator set, the energy from the batteries can be used so that one or more generator can be shut down. And when this is used in combination with the genset, the energy from the batteries, it reduces the transient voltage dips, frequency dip, and it improves the power quality to the loads. Now, we know that the power from the renewable sources is intermittent. Battery energy storage systems smooths out this intermittent power. BESS is also the right choice if you're looking to reduce energy costs by energy time shift. That is, discharging the stored energy during peak hours and charging them during off-peak hours. And BESS, when it is used with the utility grid, it provides, it allows for time shifting of energy for price arbitrage. That is, it allows determination of the best source that should be supplying power to the loads for the lowest cost of energy. BESS can also provide immediate response to grid disturbances, helping maintain voltage and frequency stabilities. Back to you, Megan.
Great. Thanks, Akhila. So we're going to switch gears now and have a conversation with Joel. So can you move to the next slide, please? So Joel, can you talk about how a battery energy storage system EV charging solution can curb peak power demand?
Yeah, sure, Megan. So if we can just go to the next slide, please. So it's no secret that as we continue through the energy transition, we're seeing more and more electric vehicles, and not only on the roads, but also on construction sites, mining sites, and even in marine applications as well. So the addition of all these electric vehicles and the EV charging stations that go along with those electric vehicles can put strain on the utility and the existing electrical grid infrastructure. So by utilizing a battery energy storage system with an EV charging station, we can actually offset that strain put on the grid by shifting the time in which we pull power from the utility. So to provide an example, let's say a large percentage of the population switches to electric vehicles, we may see a new peak demand time around 4:30 or 5 p.m. Monday through Friday, when we all get home from work and we plug in our cars to charge. Some existing utilities may not be prepared for this new peak demand load. So by utilizing battery energy storage system solutions with charging stations, we can charge the batteries during the off-peak hours and then release the discharge the stored energy during those peak hours. This solution will help provide stability to utilities and then also reduce peak demand charges for the owner of those charging stations and reduce their utility costs. And a battery energy storage system would also allow a charging station to be operated with a limited capacity, of course, during a grid power outage. Another example of where a battery energy storage system, could be used with charging station could also be in construction applications. So we are seeing more and more electrified construction equipment, such as backhoes, excavators, trucks, etc. And given certain urban areas and the daytime or even nighttime noise constraints that come with these areas, a fully charged battery energy storage system could be deployed to the construction site to charge the equipment in lieu of using diesel powered generators. This would allow the customers to adhere to any of those noise regulations and as well as reduce their carbon footprint if the battery energy storage systems are recharged using renewable energy sources. And lastly, pairing a battery energy storage system with solar at charging stations is also a great solution. Um, this would allow us to utilize the energy produced during the day by the solar to charge the batteries instead of the utility. This could also result in a reduction to the utility costs.
Great. Thanks, Joel. So we talk about electric vehicles, that can include ships or vessels. So can you give us an example of utilizing a battery energy storage in a marine charging application?
Yeah, sure. So, one application that we may see having the use of a battery energy storage system would be having that battery energy storage system installed at a dock or a wharf. So we are starting to see electrification in commercial vessels. However, the utility infrastructure and the available utility power at these locations may not be significant enough to charge the electrified vessels in a reasonable amount of time. So by adding a battery energy storage system at the docks, we can actually slowly charge the batteries using the capacity that the utility does have available, and then discharge the stored energy in the battery energy storage system for charging those vessels. This solution would allow for fast charging of those vessels.
Great. Thanks, Joel. I do have another question for you. So can we move to the next slide, please? So Joel, can you talk about what it would take to update existing standby equipment to then include renewable energy sources with the purpose of mitigating peak power demand?
Sure. Great question, Megan. So it ultimately takes an in-depth look into the customer's site, the existing infrastructure, and the purpose or the reasoning behind the addition of those renewables. So if we can jump to the next slide, please. So first off, we would require a single line diagram of the existing electrical infrastructure along with information, model numbers, all that type of stuff for the existing assets on site. So here on the screen, we can see an example of a typical or conventional single line diagram, which includes standby equipment. So as you can see, we have a utility connection, we have our load, we have emergency gen sets, and in most cases, we will also have automatic transfer switches to detect that loss of utility power and then send the start commands to the standby assets. Next slide, please. So on this slide, this image also reflects a typical single line diagram, but in this case, it not only includes the conventional sources that we just talked about, but it also includes renewable assets such as solar and then the battery energy storage system, all managed by a microgrid controller. So as you can see on the image, the batteries and the solar are now connected to that same common bus. And we can also see the little blue dotted line that actually connects the controls of all that equipment back to a microgrid controller. And that microgrid controller really acts as kind of the brains behind the operation.
Great. Thanks, Joel. Do utilities allow this type of equipment to be connected to their grid?
Great question, Megan. So I would say one of the first steps that should be done by a customer or a consultant when exploring the opportunity of implementing a hybrid energy system would be to contact their local utility authority and then complete an application to determine whether or not you are allowed to connect the additional power generation systems to the grid. This process would provide any specific rules or maybe limitation requirements that you would have to follow. And this type of information is extremely important for Toromont to really know and understand prior to being able to suggest any solutions. So if we want to go to the next slide, please. So next up, we would really have to analyze the information and then look into the site-specific location. So along with conversations with the customer, available real estate at site, etc., we can determine which type of renewable would best suit the location and the customer's needs. So an example here, if a customer would like to implement solar, a solar assessment or solar penetration analysis would have to be completed to determine whether or not solar is actually a practical solution for that particular geographic location. So to put that into context, let's say the southern half of Manitoba and Saskatchewan, as an example, has a much higher photovoltaic potential than, let's say, Canada's northernmost Arctic regions. And there's a few different softwares out there that are available to complete these types of assessments. Renewable sources like photovoltaic or solar, along with battery energy storage systems and the customer's existing conventional assets, such as diesel generators, can all be tied together electrically and then controlled for an optimized use. The solutions would be based on what the site-specific location and the local authority accepts. Can we jump to the next slide, please? So now we'll look into more of the power side of things. So on the power side, an analysis would have to be completed to determine whether, or to verify, I guess, whether the existing switchgear on site had the extra space or the extra capacity to add the new sources. If not, Toromont can provide custom switchgear solutions that we do manufacture in-house to accommodate, whatever the customer's needs may be. For controls, Toromont would provide a microgrid controller that would interface with all the sources. So it would talk to the renewable sources like the solar or wind, the utility, the battery energy storage, any gen sets that may be at site, and then it would dispatch all those assets accordingly. The controls can also be tied into a software which can actually optimize and monetize the microgrid to be the most efficient and cost-effective in real time. So this is done by automatically analyzing numerous factors, making real-time decisions, and then deploying those assets accordingly. So to summarize and to kind of circle back to the original question, which was, what will it take to retrofit existing standby equipment to include renewable energy sources? So first off, we would really need to learn and understand the customer's desired application. So whether that be saving money, green initiatives, things like that, we would try to understand what the customer currently has for equipment, determine if we can use some of that existing equipment or modify the existing equipment, or determine what new equipment may be required. We would then work with the customer to identify any space constraints, whether that be internally or external real estate, budgets, return on investment expectations, things like that. And then we would put together a comprehensive proposal for a complete integrated solution.
Awesome. Thanks, Joel. So an important question for you, is Toromont only able to work on solutions that are Caterpillar branded?
So no, Toromont is able to work with new or existing assets, and we can work with a variety of different equipment manufacturers and models, not just Caterpillar.
Awesome. Okay. All right. Thanks, Joel. So we're going to move, if you can move to the next slide, we're going to have a conversation again with Akhila. So Akhila, can you talk about if you're using natural gas generators combined with battery energy storage, will that provide diesel genset like transient performance?
Hey, good question, Megan. So when we say transient performance of a generator set, we're talking about the voltage dip, the frequency dip, and the time it takes to recover to rated values when a load is applied on the gen set. For standby or peak shaving market, the diesel-like performance characteristics that are needed are fast starting, block load acceptance capability, rapid recovery to rated values, and steady state stability capabilities. Up until the introduction of the Caterpillar fast response natural gas gensets from the 750 kilowatt to the 2.5 megawatt ratings, the best performance some natural gas gensets in the market could achieve was only about 50% block load at one time. And for the lean burn natural gas gensets, the block loading capability was much lower. It is in the range of 25 to 30%. Most lean burn units are actually optimized for utility parallel operation with only about 5 to 10% block load capability. But the Caterpillar fast response natural gas gensets can take 100% block load in one step and recover to its rated values. They do start under 10 seconds as well. Please do check out our videos that are on YouTube. You'll be able to see a 2.5 megawatt natural gas fast response genset starting in under 10 seconds and taking 100% block load in one step. You will be impressed. While it is impressive that a natural gas genset does not stall at 100% block load, you will see, however, significant dips in the genset voltage and frequency. But when battery energy storage system is used with the natural gas gensets, it does support the transient block load and the motor starting requirements, thereby reducing the magnitude of the voltage and frequency dips, and it also improves the recovery time to the rated values.
Great, thanks, Akhila. And for anyone on the that's participating today that wants that link to the video that Akhila just referenced, just feel free to email us at the email on the screen, theenergysolutions@tormont.com, and we'd be happy to share that. So Akhila, do you have a case study around this that you could share with us?
Yes, if we can go to the next slide, please. Okay, in this case study, Caterpillar did the sizing and the stability calculations to see how many 1260 kilowatt rated battery energy storage systems are required to operate with three 2.5 megawatt standby rated natural gas gensets to achieve the specified transient performance, the diesel-like transient performance, for the given site-specific loading scenario. So in this case, three 2.5 megawatt natural gas gensets operating in parallel was subjected to a block load in the first step of 1.5 megawatt. And subsequently, the customer wanted 9 800 horsepower motors to start in 9 steps. And the customer's requirement was that whenever the emergency gensets are operating, the battery energy storage system should support the transient block load and motor starting requirements. Once the emergency system has reached its steady state operation, then the battery energy storage is not required and it could be recharged, pending, of course, the generation capacity. Under normal power conditions, when the genset is off, battery energy storage system is not required again and it can recharge. If we can go to the next slide, please. Okay, here you will see that the CAT analysis was done in two different tests. In the mode 4 test case, three 2.5 megawatt standby rated natural gas gensets were subjected to the first step of 1.5 megawatt, and in the second step, 800 horsepower motor was started. And in this was done with the combination of a single 1260 kilowatt battery energy storage system, and then with 2, and then with 3. And the results were recorded, which I'm going to show in my next slide. In the mode 3 test case, it was only the battery energy storage system that were subjected to the same set of loads, the 1.5 megawatt load in the first step and the motor starting in the second step. Now, if we can go to the next slide, we will see the results more in detail. This slide is pretty busy and it will require some explanation. So what you're seeing here is in the first column, you're seeing the loads that were applied, the 1.5 megawatt in first step and the motor starting in the second step. The second column shows you the various parameters that were recorded for the analysis. The third column talks about the limits or the acceptable limits for these parameters that were measured. For instance, this requirement was the voltage dip should not exceed more than 10%. The next column that's highlighted in red shows the results of the test when only the generators were subjected to the two loads, the 1.5 megawatt and the motor starting. You will see, as you can see, the voltage dip with the 2.5 megawatt gensets was around 14.4% as compared to the requirement of 10% max. Now, the same 3 units of 2.5 megawatt was subjected to the same set of loads, but with the combination of a single 1260 kilowatt battery energy storage system. And these results, you're seeing them in the blue box. So a combination of 3 gensets plus 1 battery energy storage system, you will see in the 5th column. And this did not meet the requirements in terms of the voltage recovery time. The customer's requirement was that it has to recover within 3 seconds. And you can see, as it is highlighted in the yellow box, the recovery time was around 3.74 seconds. The same set of 3 gensets, 2.5 megawatt rated, in a combination with 2 battery energy storage systems, 1260 kilowatt rated, you will see it meets all of the requirements of voltage dip, frequency dip, and the recovery times as stipulated by the customer. In the yellow box, we subjected only the battery energy storage systems to the same set of loads, and the results were recorded. And as you can see here, subjecting the 1 unit of battery energy storage system does not make sense because the base load is 1.5 megawatt. The first step load is 1.5 megawatt, and we are talking about a single 1260 kilowatt rating of battery energy storage system. So we look at the 2 units when it was subjected to the same set of loads. The results don't we didn't get satisfactory result when it comes to the voltage dip. It's, as you can see, it's higher than the 10% specified. However, 3 units of 1260 kilowatt battery energy storage did meet all of the requirements. But the main point that is to be noted here is that the energy output from the batteries is for a limited period of time. So the best solution, of course, is the combination of the generator set and the battery energy storage system. So 3 units of 2.5 megawatt standby rated units, gensets with 2 1260 kilowatt battery energy storage systems provided the required transient performance as specified by the customer for the given set of site load conditions. One point to be noted is that the results that were captured were with the default control tunes. The recovery time in the mode 4 tests can further be improved with tuning of the over frequency, under frequency, or the over voltage, under voltage controllers in the battery energy storage system. And more accurate results can be obtained if the VFDs are also modeled into the calculations.
Great, thanks, Akhila. Can we expect that we would have the same results across all natural gas generators?
No, Megan. The results will not be similar across the board for all natural gas genset ratings. The sizing and the stability calculations have to be done on a case-by-case basis. The different models and the different ratings of the generator sets have different transient performance. the number and the rating of the battery energy storage systems that have to be added with the generator sets to improve the genset transient performance has to be estimated for the specific generator sets and for the given set of site loading conditions. And this is true for all makes and all manufacturers of natural gas gensets.
Okay, great. Thanks, Akhila. So last but not least, we're going to switch over to Habib. If you can move to the next slide, please. So Habib, can you talk about how battery energy storage can be used for fuel saving, peak shaving, as well as carbon reduction?
Sure, Megan, thank you. I would like to present 3 cases showing how BSIS is used or battery bank system is used in different applications and how customer could save fuel and reduce carbon production. If we can go to the next slide, please. This is a typical application for remote sites, which the power system consists of solar, or it could be wind hybrid ready system. And we have a battery bank power system, and we have 2 generators. Microgrid controller is used to control the power sources, and also it can control the load. BSS, battery bank system, and solars are connected to the bus, with the solar being the primary source of power in the system to energize the load. If there is a bad day, solar cannot produce enough energy, the battery bank would contribute to the load. When the load decreases, solar system could recharge the batteries and energize and provide power to the load. If there is a day that solar and battery banks are energizing the load and charge of a battery drops to 80%, microgrid controller will start one of the generators or both generators, depend on the load, how much load is available in the system. Generators will recharge the battery and also provide power to the load. Once the batteries are fully charged, generators will go offline and the cycle repeats. Solar will be energizing the load with the backup of batteries. In this application, we can see that with having a battery bank system, we don't need to run the diesel generators more often, and customer could save fuel and reduce carbon production. If we can go to the next slide, please. In this application, the power system consists of utility and battery bank system. Utility is the primary source of power to energize the load. When during a high demand or high peak time, the batteries could come online and take certain amount of loads for certain amount of time, depend how big the battery size is. When it's not peak time, the utility could recharge the batteries. Also in this application, if utility is not available, the batteries could energize the load for a certain amount of time. Again, depends on how much load is available and how much size of the batteries are. In this application, we can see the battery banks are used for peak shaving and backup power. If we can go to the next slide, please. In this application, we can see the power system consists of 2 utilities, main time main. We have 2 gas co-generators, one on each side of a tiebreaker. And then we have 2 battery bank system, one on each side. Microgrid controller will be used to manage different power sources. The primary power sources are utility and co-generators. As we know, gas generators cannot take big step loads. When utility is not available, cogen will provide the power to the load. For big step loads and electrical stability, battery bank could be used to take the load swing. And previous slides, Akhila showed that recovery response of a gas generators are much better when battery bank is used in the system. The battery bank could be charged when utility is available or there is less load on the gas generators. In this application, we can see that battery bank is used for could be used for electrical stability. These were the 3 slides I wanted to present. Thank you, Megan.
Great, thanks, Habib. Do you mind describing the best approach to take when you need to size a battery energy storage system?
Sure. We have some tools to recommend the size of battery bank system, but each application is different. Each case has to be studied separately. We need to know if the application is cycle charging, it's a standby application, it's electrical stability, how much load is in the system. Based on these information, we will be able to recommend the size of a batteries.
Okay, great. Thanks, Habib. And lastly, is a microgrid controller needed when a battery energy storage system is used with other power supplies?
In most of microgrid application or hybrid system, microgrid controller is used to manage the power, manage different power sources. Also, microgrid controller could be used to program different modes of application. It could be one point of connection for a customer SCADA or remote monitoring system, and it could provide alarms and data to the customer. But there could be an application that we don't need to use microgrid controller, and we could use Toramon's text control for that project.
Okay, great. So that actually concludes the presentation portion of the webinar, and we're going to jump in to the Q&A period. If you can just send an email if you have a question to energysolutions@toromont.com. Unfortunately, we had a technical glitch, and that's why we're having to use an email, but that's where we need you to send any of the questions you have, because the chat function isn't working. So I'm just opening up some of the questions that we are receiving, and I'll just throw it out to the group. But the question is, what are the restrictions on transporting and relocating battery energy storage systems? What about in a charged state? So that's one of 2, but I'll throw the first one out to the group.
I think I can.
Oh, go ahead.
Go ahead, Joel. Yeah.
I was going to say, I mean, I'm not savvy on the rules and regulations for all jurisdictions or all areas. But yeah, there is definitely somewhat of a concern, when transporting these. And I think the transportation methods and the handling of this equipment also is extremely important with regards to the maintaining the health of these battery energy storage systems. So yeah, that would definitely be looked into on a case-by-case situation.
Okay, great. Thanks, Joel. And the second portion of the question was, what is the surge current capability of battery energy storage systems, and what is the limitations of transformer inrush in an island non-grid tied application?
If I may answer this question.
Yep.
So as I mentioned in the previous case and the previous slides, that each application is different. We need to know the size of a transformer. Once we have the size of a transformer data and information, we will size the batteries accordingly to make sure transformers are not affecting the batteries, and batteries could energize the transformers.
Okay, great. Thanks, Habib. So we'll move on to the next question. Does the battery efficiency depend on the climate conditions of the site? Does the battery last longer in warmer areas?
Yeah, so there's, I can provide a little bit of insight on this. There are lots of factors to consider when choosing batteries and battery energy solutions, and climate, definitely is one of them. Especially here in Canada, we do sometimes have issues with a low temperature rating. So yeah, temperature definitely can be a factor. But in addition to that, there's also a lot of other things that need to be considered too. So let's say the amount of cycles. So it kind of all comes back to when we ask or talk to the customers or the consultants and try to determine the reasoning or the purpose or the function of the product. And the reason we ask those questions is because we need to understand certain information, such as like how many cycles is the battery going to be charged and discharged in the run of a day or a week or a month or a year, because things like that all come into play. So not only temperature, but the amount of cycles, things like that. As we all know, batteries do degrade over time, so that is all very important information to be disclosed upfront, and that type of information helps us choose what solution best fits that application.
Great.
And to add to Joel's point, in terms of operation, very broadly speaking, don't charge batteries at temperatures above 40 degrees centigrade or below 0 degrees centigrade.
Great. Thank you, Akhila. So the next question, are there any environmental regulations in provinces or territories to have battery energy storage systems in the field?
Yeah, I'm not sure if we can answer that one right away. We might have to look into maybe if they can follow up with what province or territory or where they're looking at implementing the system, and then we can look into that specific area and get back to them.
Yeah, because they're all different, so that's
Yeah.
the challenge. The second question in this individual's email is lifespan of a battery energy storage system and disposal of batteries in the environment. So I'm going to assume you're asking, what is the typical lifespan of a battery energy storage system and how are they typically disposed of? So anyone want to take that on?
As far as lifespan, I think it depends on the product or the manufacturer of that battery energy storage system. But I mean, we are seeing typical lifespans of 15, 20 years, things like that. But again, it all kind of circles back to the application. So the amount of time or the amount of cycles that these batteries are seeing per year may degrade the batteries quicker, which may reduce the lifespan. And there's also factors that need to be looked at with regards to the lifespan. The batteries will still be able to store energy after 10, 15, 20 years, but we need to understand how much energy is the customer looking for. Are they able to reduce the initial requirement of energy that they asked for, so that we can say, after X amount of time, you'll still get 80% of the battery usage, things like that. So again, it is really application specific.
Okay, thanks, Joel. Next, oh, go ahead.
Sorry, if I could add to Joel's comment, one of the conditions or aspect that we size battery bank systems is that how long the customer needs the battery bank system for. As Joel mentioned, is it 10 years, it's 15 years, it's 20 years. And also we can calculate somehow the derating of the batteries that, for example, after 10 years, it will reduce its capacity by X amount of percentage. And then we can add on module to it to bring it back to the original capacity.
Oh, okay, great. Thanks, Habib. Next question, are the controllers smart enough to operate the best combination of energy sources throughout the day, accounting for energy costs in each area or application? But I'm assuming that's the microgrid controller itself.
Yeah, and also there are, we can offer a cloud-based program that can actually, monitor a customer's site for them. And, that program and that software can actually predict peak demand times, and it can control the assets on the customer site. Basically can be programmed to be the most cost effective or most efficient, however that customer wants to have that laid out.
Great, thanks, Joel. Next question, does Toromont Caterpillar supply greener fuel generators, or is natural gas and diesel the only fuels? Anyone want to take that?
Diesel generator sets, well, Toromont does supply gensets that are suitable for heavy HVO and biogas, and smaller ratings of propane units are also available.
We also have the 100% hydrogen generator.
Yes, we do have one rating that's field verified and tested for 100% hydrogen operation as well.
Great. Okay, let's see if there's any more questions here. Let me just pull it up. This person asks, can we charge BESS systems up to 100%? I have read somewhere that we can only charge it to 80% and can use it till 20% battery energy left in the battery. So we only get a window of 60% usage for battery energy storage.
I think I can answer this question, but it may not be complete, and we can respond to this question later on also. Based off my understanding, the batteries are charged by the inverter, and the limit of charge could be adjusted in the inverter that it will be charged 80% or 100%. I agree that it will not be charged up to 100%, but it could be lower than that. The exact limit, I cannot point to that right now. And we could use the charge up to 80%. And then as soon as it comes to 80%, then the microgrid controller can communicate with the battery inverter that it stopped producing power and it will wait for recharging battery. So yes, we could respond to that later on as well.
Great. Okay. Thanks, Habib. Next question. Is there an opportunity to utilize what you're proposing in a UPS droops-like solution? The droop solution provide an energy efficient solution. It would also provide cleaner power to the facility with the double conversion. The droop system can also replace all the battery-backed static UPS equipment required to support the critical IT loads and the standby diesel generating equipment required for continuous power supply. So does anyone have an answer for that?
No, we'll have to get back on that one.
Okay, so we'll get back to you on that one. Not a problem. Oh, another one just came through. Just pop it open. So is there any study or research or marketing being done to determine whether we can market solar renewable systems, hybrid and battery systems for the Quebec market? If not, is this within the contents of the strategic program of Tormont? I think this is actually someone internal in our organization from Quebec asking this question. So
yeah, we'll have to
we'll get back to you on that. This question, can you please send the presentation slides from today's webinar? Absolutely. Yes, we will make the presentation available to everybody. We can send it out, and we'll also have a recording posted shortly, and you can check that out. Will be available on our social media channels as well. So that's no issue. All right, here's another question. I'll throw it out to the group. How do we minimize thermal runaway in battery energy storage systems?
I can take that question. To answer it very generally, thermal runaway can occur due to a number of factors. It could be on account of overcharging. It could be because of poor storage practice. Or it can be because of faults in the battery. So this has to be addressed during the design stage, how the batteries are being handled, the operation of the battery energy storage system, and also the maintenance stages. So talking about the design itself, including a battery management system kind of takes care of this aspect. Because using the battery management system, you're measuring the cell voltage, the charge, the discharge currents, and the temperature. and monitoring each cell to detect potential hazards at an early stage goes a long way in minimizing the thermal runaway possibility. Talking about the storage of the batteries, it should be stored at safe temperatures, typically in the range from 5 to 20 degrees centigrade. And during the operation, narrowing the ampere hour discharge window to reduce the thermal buildup goes a long way in reducing the thermal runaway, and limiting the charge rate of the battery. Don't charge, like I said before, don't charge the batteries at temperatures above 40 degrees centigrade or below 0 degrees centigrade. And in terms of maintenance, replace old batteries before they fail, regularly maintain the batteries, and check for any kind of anomalies like shorts in the cells or ground faults.
Great, thanks, Akhila. Another question came through. Are battery modules complete with heating/cooling systems to ensure correct storage and operating conditions?
Yeah, so the containers are regulated, yes, and there are some liquid cooled units now as well that are available, which actually allows for getting a little bit more energy stored into the same size of a footprint.
Great. We got about 2 minutes left here, so we'll try to get to as many as we can in that 2 minutes. So we'll throw this one out. I think Habib can probably answer this, but if I have a solar system connected to my facility with utility power and the utility goes down, can the solar system operate? Can it operate on its own? If not, what do I need to do if the utility power fails for the solar to then provide power?
Sure, again. In most of our application, the solar system are connected to the grid. When grid is not available, the solar system will not be used to energize the load. If battery bank is used in the system, we will be able to use the solar power when utility is not available. Again, it all depends on how much and what type of load we have in the system. If there is a big step loads, such as motors or other inductive loads, solar will not be able to take the load swing. And if battery bank is used, it can be used for the load.
Great, thanks, Habib. All right, maybe we have time for one more. I think this is probably a good one to highlight. Do insurance companies have requirements that you need to follow if you plan to integrate various energy systems?
Yeah, I can touch on that one. So, as mentioned earlier in my presentation, I talked about, contacting your local authority to find out what you are and are not allowed to do. So another good one would be to contact the insurance company as well. So for your customers or if you are the customer. We have seen certain cases where certain insurance companies may not allow, let's say, solar being mounted on roofs. So especially with aged infrastructure and things like that. So there definitely is, maybe some requirements that you need to follow, and not all companies will allow certain installations. So definitely good to check in with your insurance company before you go down the path of implementing something.
Okay, great. Thanks, Joel. Well, everybody, we're at time. So that concludes today's webinar and this fall's Let's Talk Energy. Do stay tuned because we will be having more coming up in the new year and all throughout the year. And again, we will have that recording of this webinar posted on YouTube with probably within a week and a half if you need to reference something. And we'll also reach out to any questions we didn't get to because there are a number of them. So we will be in touch with those individuals shortly. So we'll let you go. Have a great afternoon. And again, thank you so much for participating.